How you doing today, everyone? Good. How did yesterday's workshop go? It went. That's okay. How do we feel about pass by value, pass by reference? Is it starting to click a little bit? Yeah? Makes sense. You can follow it like with your mental model. It makes sense when you save primitives versus saving complex types. Yeah, and when we use the assignment operator, the equal sign, what are we actually changing? Yeah, we change the variable. We give it a new reference or we give it a value. It doesn't actually change whatever thing that variable used to refer to. Cool. So just a little addendum then. Yesterday and the rest of this course is probably when we ramp up in difficulty a little bit, which I'm sure you're feeling. That's totally normal to feel that pressure, especially when you have no programming experience at all, and the first half of the course just rips through the basics of programming real quick, and now we dive into deeper, harder stuff. So today we're going to move towards higher order functions, which is a concept that's really important for functional programming, a style I've spoke about a few times now. So yesterday is pretty important that we have to kind of understand how that works under the hood and have a feel for it to really be able to use complex data types effectively. But the rest of what we cover in this course is really great, and it's really powerful stuff that can make it a lot easier to solve problems. But if you don't get it the first time around, that doesn't mean that you can't do this or you can't become a developer. It means that you can revisit older material to feel better about the stuff we covered in the first half of the course, which will free up headspace to then be able to incorporate some of the stuff that we're going to go over today. Pass by value reference, we can't really escape that. That's really important. But functional programming and passing functions into functions, we can kind of use more basic tools if that's what you're more comfortable with. And you could definitely pass the assessment without needing to use higher order functions. But you'll see some examples of how, like the filter yesterday or the map, is a lot less lines of code than a bunch of for loops where you do everything. So I read something yesterday that explains the difference a little bit better. Imperative programming, where we use for loops and we move indexes around, that type of code explains how to get things done. And you're really manually doing a lot of the operations, which means that there is one, more code, two, a lot more places that you can make bugs or mistakes, and three, it's not as readable. You really have to translate what that for loop is doing and read every line of code to know what the code is supposed to do. But functional programming, when we had something like nums.map and then double nums, this code doesn't really say how to get that done. Instead, it just describes what is being done. And they both, under the hood, they're going to do the same thing, but the top level code that we read here is a lot more readable and describes what is being done rather than listing the instructions on how to do it, which then has to be translated in our head. And so that's what the big benefit is. We can write less code and we can read it. But if we don't have the headspace to write in this style, that's perfectly fine. You'll be aware of it to come back and incorporate these tricks once you're better with everything else earlier in the course. So functional programming isn't going to be required to be able to pass the full stack assessment, but the last topic we cover next week, recursion, which is when a function calls itself, and we'll get into that next week, there will definitely be a question on the assessment that can only be solved with recursive programming. So to give you an idea of what that looks like, we have a nested array here, and we have another nested array over here. And so the problem that you're going to see, I'm giving you a freebie here, is going to ask you to sum up all of the numbers no matter how deep this array goes. So there's no way that we can write declarative code that can sum up all of these numbers, because you need to basically hard code for this. The first thing, we need 2 for loops to get inside of these numbers. And this one over here, we would need like 10 for loops to get inside of that array. And as soon as somebody comes to you and adds one more bracket around this, your entire code is fucked and you can't grab that number out. So this is something that requires recursion, which basically means, hey, is this value an array? If so, let's go to the next array inside and pass that into the same function. And it'll keep doing that until it ultimately finds a number that it can sum up. That's okay if that makes no sense, but recursion is what we use when there's nested data structures that we don't know how deep it goes, and those types of problems can only be solved with recursion, and that will be on the assessment. But if we gave you a function where we said return an array that basically replaces all the numbers times themselves times 2, if that made sense, I just tripped on my words. But anyway, we don't care if you do that with a for loop or if you use the map function. Sure, the map function is going to be easier to write once you get it, but it can be solved either way, and that's entirely up to you. So we'll get to recursion next week, but don't stress. This is a marathon. Yes, this is a marathon, not a sprint, which means you're not racing to get into the program or to become a developer as quickly as possible. Sure, you might want to, and you might want to make money and switch jobs, but if you go into the program when you're not prepared and you're not fully grasping the basics of how the code works, and now we're teaching you how to set up a server or how to set up a complex web app and what the native functions look like to do that, you can't really just memorize syntax to solve problems. You have to actually understand what's going on under the hood so that you can solve the problems that are unique to your application. And so if the entire time you're in the program, you're struggling to keep up with what the code is actually doing at this type of level, you can't really wrap your head around the best practices for setting up a server or how to solve problems on the front end, and you're doing yourself a disservice because you're not going to get as much out of the curriculum as if you went in when you were more confident in your coding ability. So there's no reason to race through, and if that's not enough that you won't understand enough during the curriculum, well, if you go to the job search and you don't know what you're doing, it's going to be fairly obvious, and you're not just going to get a job handed to you. So we really want to go in when we're ready to take in as much knowledge as possible so we can come out as skilled as possible, because the career is skill-based. And how well you do in interviews is going to determine what job offers you get and how much money you get and how quickly you get promoted and make more money. So the whole thing is a marathon where we're continually trying to learn and improve our skill set, and we can't really just force ourselves to do it as quick as possible. Everybody needs to go at their own pace, and be patient with yourself. Don't get frustrated the first time we see something like that and have no idea how to implement it. That is totally normal, especially without any programming experience at all. So I hope that calms some nerves a little bit. Lastly, the curriculum in LearnDot doesn't go away. You'll have it forever, that login. You'll always have the workshops to redo. You'll have the solutions. You'll have my videos. You can revisit this as often as you want, or even take the course again at a discount, I believe, if you want to do that. And I have many students who do. And they do much better the second time around because they have more headspace because they understand some of the other things. Yes?
So we're taking an assessment at the end of this class, though, right? That won't necessarily count.
Yeah, so at some point next week, somebody actually from Full Stack will come to talk about the assessment and the admissions process. I'll give you a quick summary. So what is next Thursday is the last day of class? So on Thursday, we will take a practice assessment. So you're going to learn how to log into HackerRank. You'll get familiar with the environment, and that's great because even job interviews will use the same exact environment. It'll be the first time that you're kind of coding alone and solving problems completely on your own, which might be a bit different than pair programming. So all of that is great experience, and you'll get to solve problems that aren't really just implementing some of the things in our slides, but actually trying to solve problems that have nothing to do with code, and code is just your tool to get the correct output. So it's a little bit different than some of our workshop problems. Anyway, it's completely diagnostic, which means there's no real grade. You'll know if you pass the test cases or not. You'll know, hey, I struggled with this array problem, but I did really well with objects. I should probably go study up on arrays again. So it'll help you find your weak points so you know what to practice, and we'll talk about how to practice before you take the actual assessment. So next Thursday is complete freebie. It's just for you, for your own knowledge and practice. Immediately after class ends next Thursday, we open up one more diagnostic assessment. And so that one, I think you'll have to complete it in about a week. It'll be open forever. But if you complete it in a week and you do well on that one, you immediately skip to the Full Stack interview, and you don't have to take the other assessment that we have on our homepage or Full Stack's website for people who just apply on their own. And again, if you do poorly on that, it doesn't matter. It's not used against you at all, so there's no reason not to take it. If you do poorly, it's just for you to know what else to work on, get some more experience. But if you do well, you get to skip that stage, and that's great. Otherwise, you'll take the actual assessment through their website at a later date when you feel more comfortable. And then if you pass that, you go to the interview.
How we can know about results?
Yeah, so it's going to be similar to CodePen. You're going to write code in some editor, you're going to run it, and it's going to tell you, hey, you failed these tests. So if you pass all the tests, you're probably good to move on to the next problem. So mentally, you just keep track of, hey, I failed these, and they had to do with this. Because I don't think you get to see the code again.
And how many tasks we can have?
So all the assessments are going to be 4 to 7 questions. I believe the 2 that we give out are 5 questions. And it'll be an hour, 15 minutes to take it. So I'll talk more about that next week on how to take that test and how to budget your time, which might be a little different actually trying to code something under pressure and managing that time to at least get a significant amount done and not get stuck on one problem the entire time. But we'll talk more about that before you take it. Cool. Any questions on that? Does that kind of make sense for where the rest of the course goes? Cool. Any questions from anything so far or yesterday's workshop? No. We feel good. Okay, cool. So we're going to take a step back real quickly. Most of this example we're going to do relates to objects and methods, which we did last week. But I think this is a good example to show kind of real life code. So what we're trying to do here is we're trying to mock up the functionality of a phone book in real life. So a phone book is basically, we have phone numbers and you look up a phone number and you get a name, right? And we want people to be able to add their name and number to this phone book. We want to be able to look people up. We want to be able to remove numbers. And we also want to be able to log out everybody that is inside of that phone book. So I've set up an object here, which is great to represent real life functionality with methods that will make this function like a phone book. So we've got this variable phone book, and it is what? Yeah, the phone book variable is a reference to this object that will have our phone book functionality. And so I've got a skeleton of 4 methods here. And I have something called directory. Why do we think my current directory is 1, empty, and 2, it's an object? Yeah, how am I going to use this thing?
Well, you're gonna have a name as a key and like a number as a value.
How do we think I'm going to use the directory? Yeah, and how do we think we should store those? So not the code, but what is going to go into that directory object?
Objects and names and numbers.
Yeah, but which is which? What's the key and what's the value? Sure, but if we've got a number and a name, which one should we use as a key and which one should we use as a value? Okay. How many people do you know that have the name Chris? Probably a few, right? So if I put Chris in there and then another Chris comes and wants to put his number in, what happens? It's going to override it, right? Yeah. So this is what I'm going to demonstrate here is how many of us have heard of this concept of like data structures? You'll mostly hear that idea. It's a common interviewing topic. What are data structures? What are ways that we can use programming data types to model some type of data structure that represents something in real life? So objects are our data type, but a data structure that is really useful is a hash. And so that sounds really crazy at first, but so let me explain it. A hash is basically when we use an object to do nothing besides store unique keys and values. So in this case, what we're going to do, what is unique, the name or a number? Only one person can have a number. So in this hash, we're going to store unique phone numbers and map them to names. It's just an object that we're specifically using only to store numbers and names. And what do we think the benefit is of So here I've made two data structures that both kind of store the same information. They both store lists of names and numbers. But functionality-wise, do we see what a benefit of using the object or the hash would be over using the array? It's not ordered. Oh, I fucked that up. So with these two data structures, if somebody came to me and said, I want to know whose name is 123, how do I do that using the object? I go to the directory and I do what? Yeah, I just literally give it the number and I get back a name, right? What about if I store things like this? What does the code have to sort of do for me to find this value? I have to loop, right? So what happens when we have a billion phone numbers in both of these data structures? What?
Well, slow down.
Is it going to slow down for the object? That's the benefit of the hash. So with the hash, with these unique values, if you give me a unique value, I can look it up in what's known as constant time. It doesn't matter how big that object gets. I know I'm looking for the number, I can find it instantly. But if we stored it as an array, we measure things in the worst case scenario in programming. So pretend that there's a billion other numbers here, and this is the last number in the array. If I want to look up this number, I potentially have to loop a billion times before I find the one that has the number that you're looking for. So that's the reason that we're going to basically use a hash to store this directory, which is just this. It's just an object where we specifically only put in unique keys and values and use it in that manner. And it allows us to look up in constant time. So this will scale way better than putting it in an array where I can't look up instantly. I have to look up. So one little detour then. How many of us have heard of the concept of big O notation? So O notation is just how we measure the runtime of different algorithms. And so we always measure the worst case. So basically all this means is that to find a number in this hash, we say it takes 1, which means constant time. It doesn't matter how big that hash gets, we find a number instantly. But over here, to look up a number in an array, in the worst case scenario, we're going to do n operations, where n is the amount of data stored in that array. So if we have a billion numbers here, our worst case is that's going to take us a billion lookups to find what we want. So we just say that that's O of n. Whereas here this is constant. Doesn't matter how big it gets, it's O of 1. We'll talk more about that, but that's what O notation is used for, and how to show the difference between these two algorithms to look up a number. Yeah?
I understand that for the array you have to write the loop, but under the hood, does it really work differently when you have an object? Like it doesn't loop, how does it find the number if it's not going through them?
Yeah, so that's kind of why it's called a hash. But basically, when we're going real low level now, but when we make an object, it reserves a huge chunk of data somewhere in memory. And when we give it a key, it basically runs it through a function where each key will uniquely tell it what memory address it should store that value at. So it just knows, hey, 1, 2, 3 maps to whatever other value, and that's the value of the memory address where this thing should be. So that's very low level. We don't have to worry about that at all, but it is a good question. It can find it instantly. The array, we have no choice. Cool, so with that in mind and understanding why we're going to model this thing as an object, take a second to look at these methods. Do we kind of understand what I want to do with these methods, functionality-wise, what should happen? So add a number, we need to store a new listing in the directory. Look up number, we basically take in a number, we need to return a name. Remove number, we want to completely delete one. And list directory, we need to visit each one of them and log everything out. So taking one more jump, what is the runtime going to be of lookup directory? ON, yeah, no matter what, we have to visit every number to log them all out. So this is going to be O of n runtime, where everything else is going to be O of 1, because we're choosing to use a hash. Anyway, take a second to just think about what the implementations would be of this function, and then we'll code it. All right, so adding a number, we're going to take in a number and a name. What do we have to do?
Set the number key, so like let number equal this dot phone book bracket number, and then we'll assign the argument password to that new object.
Okay, so what is the let for then? Okay, so first we need to access this directory, right? We need to access the value of the directory. How do we do that?
Almost done.
Place dot directory.
Directory bracket number.
What's the difference between these two lines of code? So, if we did put phonebook.directory here, that's always going to look for the variable called phonebook. But if later down the line we change this, that code is broken. And also, if we have multiple phone books, which we'll get to in a minute, that one's only going to look for that specific variable. It's not really making sure that it's operating on itself. So we never want to use variable names inside of methods that want to operate on themselves, because we don't know that that variable is always going to be phone book. Later down the line, I could reassign phone book to something else and reassign this to a totally different variable. That method is broken. So instead, we want add number to work on the object that it's a part of, always. We don't care what the variable is called, and that's what the this keyword will let us do. So we select this dot directory, and then we're saying we want to go one level deeper, and we want to assign something in this directory. What is my key? Number, yeah, we said we want to take the number, the index of the number in the directory, and we want to do what with it? Yeah. So what are some things that I would maybe have to consider if this was real life and I always wanted this to work?
You have to check if the number exists before.
Yeah, one, I would want to make sure that this is actually a number. Maybe I'd want to make sure it's a valid telephone number. And two, maybe I would want to check if that number was already taken. And if it was, get confirmation that we should override it. We don't care about that right now, so we're just going to completely trust the user, put the number inside, and set it equal to the name. What about look? Yeah.
Do you use brackets instead of a dot around number because it hasn't been defined yet?
What's the difference between these two lines of code?
Numbers, variable.
Number is dot number is the key. It's gonna look for a key that actually says.
Yeah, so on line 19, this is saying this isn't using our variable. This is basically hard coded to say go add a property called number to that object. And when we have the bracket sign, this is basically saying evaluate whatever this is, the code. Evaluate number, get the actual value of that thing, which will be some digits, and use that as the key. So that's a little bit review from last week, but that's actually a really important differentiation there. That we use dot notation when we know exactly what we're looking for, and whatever comes after the dot, letter by letter, is going to be the property or the key that it's looking for. It's not actually interpolating, hey, what is the value of this variable? So in this case, if we have a dynamic key, we have to have it evaluate that variable. Yeah.
I just remember the machine example. I thought they did use dot to assign.
So sure, we can.
Was that like a different example because it's not a number, like it was a string? Is that why it was different?
So on line 7, we said go to Percy, make a key that's literally called AGE, and set it equal to the number 24. And on line 8, I know this is really confusing names and values, but on line 8, I said go to Percy, evaluate the string value of this variable age. So it plugs in 24 here and stringifies it. So you can imagine that this kind of becomes. And now that's not real code, but that's kind of what the translation is there. And sets that equal to 24. So both of these functionality-wise are completely different. In this case, we said we need to evaluate this variable, and the string value of that is what we want to use as the key. And here it's hard-coded. So over here we have a different example. This is accessing now. So here we said literally go find that key, dot age. And over here we said, wait, before you go look for a key, solve this expression. And it smashes the 2 and the 4 together and then looks for that key. Maybe that illustrates it a little bit better. Does that make sense? So this is definitely really important for working with objects. Yeah. Can you ask me more of a question so I know how to tailor this better? Like which aspect are we having trouble understanding?
I'm actually still having a little bit trouble understanding the difference between the dot notation and the bracket notation. And can we go over like the actual line 6 all the way to line 8?
Yeah. So on line 6, I make a variable called age, and I give it the value 24. On line 7, when I say person.age, this has nothing to do with any variables. I've hard-coded this to find a property that literally is AGE. This has nothing to do with the variable at all.
Is this
So-
page 24 global? It's not in the object yet. Right?
So maybe this will help a little bit to... Okay. Okay. One more time, where was I?
Oh, I see.
Age is not a variable.
Yeah. So line 6, we make a variable called myVar, and it has this string value here. On line 7, we say go find that person object, and now access a property that's literally called AGE. And in this case, it doesn't matter if it existed yet. We're completely making a property that the key will be age, and the value will be the number 24. But on line 8, I'm saying go find that person object, and now solve this expression in here. We can plug in whatever we want in here. It's just code inside these brackets. And it's going to do an order of operations to basically evaluate this expression first. So in this case, it says I need to find something called myVar, which is a variable. Looks up on the scope, finds the variable myVar, sees that its value is this string, and it basically plugs that string in right here as the key. And that's basically the next step of that order of operations is this. It plugged in myVar, put in this string, and now says, okay, we're looking for a property called favorite space thing, and we want to set that equal to JavaScript. So then when I log out person, we log out the whole object, and then here I say go to person, but find a property called age. So it goes into this object, it finds the key age, and it says, okay, you wanted this value, 24. So the brackets is kind of like a password. It's saying like evaluate this thing and use it as the password to get to that value. It's dynamic. So anytime we're going to have spaces or maybe numbers or like smashing things together or any expression, it has to be done dynamically in brackets. I can't do person.favorite space thing even if I know that exists. That has to go in the brackets down there. So you'll only see dot notation when we know for sure this property must exist. And any other time we're going completely dynamically with the numbers, it's got to be in brackets because we don't know. We can't hard code that.
So in directory, you didn't hard code a number because you want it to be an actual number that's different every time. Is that what you're saying? It's not an actual key called number.
Yeah, exactly. I mean, if we had this line of code down here, every time we take in a name, we would make one property called number and set it to the new name. We would never have more than one property called number, and that's going to be completely useless. So instead, we want it to take whatever actual number we got, stringify it, and use that as the key. Does this example make more sense now on how to access objects? You're probably going to use more bracket notation in real life, honestly, because we're going to put dynamic data in things all the time, and we can't hard code assuming what that data or that key will be. We use dot notation when we know something must exist, but look at the difference with 14 and 15. Console is actually an object. And we've known that console must have a log property, which is why we do .log. But really, I access it the same way down here. I'm just saying, hey, go evaluate this string. It's the string log. And it says, okay, I'm looking for a property called log. I found it, and it is a function, so you can invoke it like this. You won't see console log written like this because it's harder. But we know it exists, so we use dot notation.
So in line 12, you console.log.
Please, a little louder.
Oh, sorry. In line 12, you use console.log person, and then you use the bracket notation for the variable. But you put the value of the variable in it, and it gives you the JavaScript.
Yeah, so in this case, I mean, I knew that favorite thing is in there. This really has nothing to do with a variable. Like, I put it on through a variable, but I was just hard-coding an example down here. This is basically hard-coded, that it's always going to look for favorite thing. That has nothing to do with the variable. So if I change it to this, yeah. So what about in this example? What properties will exist on person by the time we get to line 10? Yeah. So we definitely have an age. I hard-coded that. And the other one says interpolate what my var is. It's this string favorite things. So it's going to go make a property called favorite things, which means on line 12, when I've basically hard coded, it's only in brackets because I needed that space. Is there anything called favorite thing? No, so if I run this, what gets logged out here? Yeah, it's undefined. And if I log out, shit. What am I looking for on line 13 this time?
My bar.
So I'm not looking for my var. It's going to say, what is the value of my var? Oh, it's this string favorite things. So I'm looking for something called favorite things. And that one would actually be found. So person.age is 24. Person.favorite space thing is undefined. And person where the key is the value of my var, which is favorite things, the value of that property is JavaScript. So arrays are objects under the hood. You've mostly used, oh, that thing is so annoying, that little power thing. You've mostly accessed arrays with like a numeric index, right? But actually under the hood, arrays are objects, so it is converting that number to a string and looking for a property called 1, which is why I can also access the same value of this numbers array with this string here. You won't see it because there's no reason for us to write it like that. I'm just showing you that you've actually used bracket notation this whole time, and it doesn't work any differently on objects than it does on arrays. So over here, I said I want to go to an index inside of my numbers array, and the index I want is the result of doing this expression and stringifying it. So 0 plus 1 is 1, and the string of 1 is the string 1. And that's the same as if we just plugged in the number 1. So you've been using this the whole time, and that's because under the hood they are actually the same thing. An array is kind of just an enhanced object in JavaScript that gives you push methods. Just like we're making an enhanced object down here that will have its own methods.
Also, the indexes are just hard coded.
I wouldn't call them hard-coded because it depends on, what data we put inside of this thing. But yeah, JavaScript is automatically making those keys for you and keeping track of how much is inside of your array. Yeah.
Sorry, last question on this. So when you created an object, and to create a key in the object, we don't have to say let. We can just do
Yeah, so let is used to declare variables on your scope. But with objects and arrays, we've already created the variable that refers to where that thing lives. So we access it through a variable that's already created, like nums, but we don't have to use a keyword to add a property to it or to add an index. So for what it's worth, nums, it looks like we only have 3 things inside of here, right? So we don't usually assign things into arrays like this. We want to use the method so that they keep things in order and keep it nice and tight. But we see here when I basically forced a value into the 100th index, it automatically filled in like 97 empty items in between this one and the one that I forced in there. That's because this is just an object under the hood. But I didn't need to use a let or anything to add on there because nums already exists. I'm saying go access nums, pull up that reference, go into the array, and at the 100th index, force this value 10 inside of it. So it's okay to ask more questions because I want you to have your questions answered and understand how these things work when you use it. Yeah, we'd cut into workshop time, But that's okay. I want to help you out. So if you have more questions, we can cover them. But this is actually really important, so I'm a little nervous that if we didn't do this example, we would have been really confused on the bracket notation. Because this is definitely more important than today and yesterday, because it doesn't matter if we don't get passed by reference if we're not even using objects correctly. That's not a dig at you, but it's an important topic, so this is definitely something we want to understand, because this is the basics of working with these things. Do we kind of get the difference between bracket notation and hard-coded dot notation now? Yeah? Continue with the directory? Cool. Yeah.
When we're done, would you mind sharing any useful resources that relate particularly to this?
Yeah, so this is a problem that I don't find good resources that walk through it as slowly as needed for beginners to really grasp this. And people ask me all the time, and I don't know the best resources, because a lot of them will just have a fucking code sample up there and say, this is a key, this is a value, use it. And it's like, it doesn't translate exactly how to think about that and how it works. So I'll look for you, but most of the stuff I find is like, yeah, this makes sense if you already know programming. And it's really hard to find something that really goes step by step by step. Which is why maybe I should build it, I don't know. I'm too lazy to make content. I just want to code, but yeah, I'll let you know. So moving on to phone book example. Now the other side of objects that might have been confusing then is that this keyword is also really important. So I guess I'll do one more demo of why this would have broke.
Just the main confusion for that bracket number was that we were creating a new key as much as setting up the possibility to create new keys. That was the confusion.
Okay, one more time.
You clarified it very well, but I'm saying the only confusion for me was that the number dot slash name, we weren't creating a key, we were just creating a possibility to create new keys later, basically.
I don't know what you mean, line 36? Yeah, so that's saying let's go to that object,
Later.
let's find a property with this number. It doesn't matter if it doesn't exist because we're going to instantiate it now to hold that value. But just to take the step back about the this context, which obviously if we didn't get the bracket stuff, the this lecture probably didn't make much sense either. But so let's just say we hard-coded phone number in here. Okay, so one thing. I called add number function with this argument. When I ran the code in the directory, why is this value undefined? Find the bugs. Because what? Yeah, I didn't pass in a name. And so this variable exists, it got instantiated, but I didn't give it a value. So name's value was actually undefined. And that's part of the problem with JavaScript, is that lower level languages like C++ would immediately flip out and break before you ever run the program. They would say, hey, you're trying to access something that's not going to take a value. But JavaScript silently did it. And if I put this in production, maybe we go a few weeks till someone checks the database and says, oh, we have no names. So that's why we always have to worry about variables in JavaScript, which allows it to be really flexible, and that's nice, but at the same time, this can bite you in the ass real quick, which is why it's good that we logged it out immediately. Anyway, let's put a name in there. Okay, great. That's working as expected, right? Now, so this is using a little bit from yesterday's lecture, but try to, in your head, figure out what happens with these two lines, 56, 57. And what's going to happen when line 58 runs?
It's gonna update it.
It's modify our phone.
What's that?
It's modify our phone.
So we think 58 is going to work.
No.
Why not?
Because phonebook is not being reassigned. So
Yeah.
on phonebook.directory, it's not going to find a value for
Yeah. So review from yesterday. We create this object. The reference is on phonebook. Phonebook holds a reference to this object. We go through that reference, we add the numbers, no problem. Then we make a new variable and we say that variable should be whatever phonebook currently is. And the variable phonebook is what? Not yet. It's a reference, right? So PB2 now takes the same reference. So right after line 56, does PB2 strictly equal phonebook?
Yes.
They're the same reference. Now on line 57, I reassign that phonebook variable to be the number 10. Does PB2 still exist? It does. PB2 is still the same reference. It actually still is this thing we created earlier. I've just moved it to a different variable as the only way to access it. So we actually are able to go through this reference and call this add number function. But when we go into the add number function, what happens?
You can't find 37.
Yeah, it's looking for a global variable phonebook. And phonebook on the global scope is now what? It's now the number 10. So if we try to access a property of a number, what do we think is going to happen? So error, or does it just silently fail? Yeah, this is definitely going to be an error. We can't set property 1, 2, 3 of undefined. Basically, directory doesn't exist on the number 10 because that's what this thing now is. So that's the problem here, that we hard-coded this variable and we assumed we're always going to go to that variable. But really, we want this function to work on its own reference. And that's what the this keyword does. That means I don't care what the variable is. However you got to me, I want to use the same reference you're currently on to access my own directory. So if we switch it back to this, the this keyword doesn't matter that we change variables all around. Later, that phonebook is now on a different variable, but it still has everything inside of it that we wanted. That's important. Yeah.
It would still not work without line 56, right? Like if you change the this back to phonebook.directory, because technically, if you want to add number in PB2, the function would read phonebook.directory, but since the object is called.
Okay, that was a lot. I've kind of lost you. What's
So-
the first thing you want to do?
So if on line 37, you change it back to phonebook.directory,
Okay.
and then you try to call the add number function on PB2, it would still not work even without line 56, right? Because when you try to call the add number method,
So
the object is now called PB2, so there it would stop working.
what do we think? Rest of the class. Same reference, yeah. So on 55, we said PB2 should now be the same reference that phonebook is. And so even though we go through PB2, we still end up inside the same object. They're the same. And so over here, phonebook is still the same reference. So it is the same object. That actually is still going to work. I mean, this is really bad, but it actually will work because we didn't do something like 58, 56, which could very easily happen. So in general, if we're writing methods on an object, to access that object, you always want to use the this keyword. I will see that in the next example, whereas what if I wanted two phonebooks that do the exact same thing, but I need to keep their directories separate? We'll get to that, 1 minute. Okay, so let's just fix this. All right, now some easier ones. How do we do lookup number? How do I access the directory that's of the same object that's calling lookup number?
Again,
What?
Again, these.
Yeah. Yeah, so on whatever just called lookup number, we want to access it. The same reference you just called this function from. So that's with the this keyword. And we say we want to go to the directory. What do I want to do in the directory? What am I looking for? Yeah, I want to look up this person's number, right? So how do I do that? Yeah, because this could be any number. I can't do any hard code because this should be able to work for 7 billion numbers in the world. So I'm saying evaluate what that number is, get the string, and this right here, what we've selected so far, will be a value. It's either going to be a name, or if it's not in the directory, what will it be? Undefined, yeah. So if we're really lazy, we could just straight up, we could just return this, and then we'll see. So the only thing we added to the directory is 631. When we look up 631, it does find that key and gives back the value Chris. When we look up this number we haven't added, it gives back undefined. So that's working, but probably in real life, we don't just want to say, yeah, here's undefined. That's the person you wanted to call. So instead, how can I check first if the number is in the directory? What is it?
Put the line, these directory numbers.
Yeah, so
Number in
Oh, the
directory.
use the exclamation mark.
what's the difference with these two lines of code?
Line 40 checks if it's true.
Yeah, so line 40 is saying plug that number in, get the value. So sometimes you might have a string, sometimes it might be undefined. And say whatever value you got back, check if that's truthy. So theoretically, if I stored like a number 0 as somebody's name, and their number is 1, 2, 3, right? If we put 1, 2, 3, let me just. So if all I have, basic Boolean right here, this is emulating if I said if test 213. So first it's plugging 213 into test and that resolves to what?
0.
0. Yeah, and I'm saying the Boolean value of 0 is falsy. So this actually isn't telling me if this number is in the object. It's telling me if the value is truthy. So sure, if it's undefined, it'll be falsy. But this could be a problem if that key was actually in there, but for whatever reason, it's a falsy value. So I want to be more specific than that. So I don't want this one. I want to use this operator that will definitely tell me if the key is set. I don't care what the value is. Just is that number in the directory? And if it is, we can return it. Whoa. So we probably don't want to throw an error and stop the program, but just for demo purposes, we will. So now when we run this code, we look up the number 631 because that number is in the directory, so we return the value. But if we couldn't find the number in the directory, we throw an error and stop the whole program, just for demo purposes. It says, hey, we couldn't find 1, 2, 3 in the directory. And then I did the template string here, which I've shown you a few times, not important, but it's kind of a similar idea. Here we're saying interpolate this variable. That's kind of the same way that the bracket notation works. It says, solve whatever expression is in here, and then give me a string value. So that's working the same way as brackets, but we don't have to worry about that. So, yeah, I'll leave it. Okay, how do we delete a number? Keyword delete. And so what are we going to do? We want to delete what? Yeah, so this is saying go to the directory and delete this key. If I leave off these brackets here and I said delete this .directory, what will happen? It's going to come and just completely wipe this out. So that's the difference of if I put the brackets or if I'm deleting the property off of the entire phone book. And so here I'm going to be lazy. We're just going, like, nothing bad happens if we delete something that didn't exist. So I'm just going to leave it like that and not pretend it's real life where we might want to tell you, hey, that number didn't exist. All right, so last one, list directory. I want to visit every number and name in the directory and log them out. How can I do that? Okay, so before we go forward, yeah, key in programming terms, this is what we're using. It is a key. But in our terms, the key means more than that, right? What is actually the key in our functional terms? Number, yeah. So we should call it number because that makes it a little bit easier to read. So we're saying for each number in the directory, we can, how do I get the name? This? So if I ran this, what would the name be? What would the value be for name? Undefined. Yeah, we shouldn't have any key called number. That's what it's looking for. Okay, so now putting it all together to make sure these things work, we add the number 631, we add the number 123, we log them out. Then we remove 631, so why do I get the error here? It's our own error. Because we try to look it up after we deleted it, right? So that's annoying me now, so we'll get rid of that. But afterwards, we look up the number again, which isn't logged out. So we look up 123, we find FSA, and at the end, we list everybody in it. We only have 123 and FSA. Does that make sense? So do we think these functions, if we're good on the this and we're good on the brackets, what about the implementation of these functions? Do we find that difficult? They're pretty simple, right? I don't want to put you down if you don't fully grasp it yet, but it shows you that we kind of just made a real life object. Like this will function like a phone book, and it's not that much code, and the code isn't that hard once we at least get the bracket notation and the this keyword. Okay, so this time we want two phone books. We want one for everybody in America and everybody in Europe. So I make a phone book, it's called American Phone Book, and I basically want another one. So I do this, right? Yeah, so later we do the same thing that we just did, and later we say, okay, it's time to start using our European phone book, so let's list everybody in it. And what happened? I haven't used the European phone book at all, but I apparently have full stack's number in there, and they're not in Europe. What is wrong with line 59? Same reference. So no matter which variable I used, all of that mutation is still there. I don't actually have two separate phone books. Any ideas? How can I get another phone book without copying and pasting all these lines of code? So we make a new reference every time we hit the curly braces, right? Every time we hit this. Well, how can I make that happen in a way that I can have it happen whenever I want? I'm really leaving you out to think on this one to try to come up with it. How can I make something happen on demand in code? A function, right? So why don't we do instead I'm trying to make it small so we can see the whole thing here. Right, so we just made a function called make phone book. Every time we call this function and it hits the return keyword, we hit this curly brace, right? And when we do, it's an object literal, which means go create an object, right? So basically, we have one template for how a phone book should work. And every time you call this function, we'll go make a new object and return you a new reference. But I don't have to have this copied and pasted throughout my code base. I don't have to have these functions in many different places. I can now make an app that'll have thousands of personalized phone books for you. And it didn't cost me anything more than figuring out the logic to have one phone book. So now, what do I have to do to get two phone books down here that are separate? Just write that? Yeah, so I say I have to go to that function. I want it to run. When it runs, it will create a new object and return me that reference that I can capture on American phone book. And now, for European phone book, I do the same thing. And we leave the rest of the code exactly the same. And now, when we go to the European phone book, it's completely different. We haven't used it at all. There's nothing in the directory. Does that make sense? Yeah, so honestly, that's pretty... I think it's a really good example to put the concepts together and show how these actually get used in real life. But this is definitely deep. This is the best way to do these things. So it's okay if we didn't fully know, hey, we can put it in a function and return it. But if we understand how it works, then we're somewhat grasping pass by value, pass by reference. And I'm happy with that you knew that the phone books were going to be the same and we'd have a problem. This is how you fix it. And this is how we can basically, this is called like a generator function. We have our recipe in one spot, but by returning it out of a function, we can make as many as we want. And all of those references are completely different. So now do we see why this would be really problematic? This function has nothing to do with any variables. We have no idea how this is going to be used. I'm going to put this online called Make Phone Book, and anybody can download it and use it in their code base. But my methods can't know what your variable possibly will be. They only know that if you have a reference to this thing, it should work on the thing that you're calling the method from. And that's the this keyword. Cool, so that's a little bit of a review from yesterday. A bunch of review on objects, so I hope that helps because objects are extremely useful as we see the difference between that array of numbers versus the hash. Objects are usually the best way to store data if order doesn't matter, but beginners often just want to use arrays because you kind of start out with arrays. And objects seem more complicated, but once we get bracket notation down into this keyword, you can do a lot more functionality with objects than with arrays. So this is pretty good. This is basically an app. This has real life functionality. We can now just wrap it with a server that when you call Oops. So how this works is myphonebook.com basically will redirect you to a server where we have a JavaScript app that's listening. And in there it has a special pattern that it says if any request has /name, we want to take whatever comes after the next slash and call our lookup number function and pass in that name Chris. So there's just a little bit of extra code we'd wrap around this phone book for anybody in the world to be able to look numbers up. And this is kind of how requests end up getting mapped to code. So that's what you'll learn on actual full stack, how to write the thing that handles this request. But if you go to So over here, now this might make a little bit more sense how web requests work. They have a pattern that says the first thing that comes after the slash, we should use that to look up a Twitter user by their handle. And that's going to be in a hash. Because Twitter has billions of users. They can't loop through an array and find Dan Abramov. This guy created React. He works at Facebook, so you'll learn more about him. And then it says, if there's something after that called /status, this big thing over here is what? What do we think that represents? That's a randomly generated unique number that maps to the actual content of this tweet. So actually the phone book data structure we just created works very similarly if we wanted to instead map random numbers to tweets. And when you go to create a tweet, we'll generate a random number, we'll put it in that hash, and then the value will be this content. And when we send the content back, the front end says, okay, I know how to use tweet.username and tweet.content and where I should put it on the screen. And that's how all of these things come together. So again, that's not trying to overwhelm you, but I think it's really cool once you start to see how the basics that we learn will tie into how real life works. And the extra steps to wrap this with the server isn't that hard, because you basically, if you know how to do the phone book, it's very similar how we would map tweets to an ID. Except maybe then we'll add in a database, but still. Cool, so now you kind of know what's going on if you see these URLs. Generally where you see user data, like Dan Abramov, or numbers, those are patterns that it's going to use as variables. Whereas status is kind of telling it what function it should run. It has a pattern when it says I have random name, then status, then a number. It means go find this tweet by this user. All right, so because we're going into higher order functions, I wanted to do an example where we don't have to use a for loop here, but because we spent a lot of time, I don't want to overwhelm you, we'll just move to slides. Any further questions? Cool. Why are functions in JavaScript special compared to other variables? Yeah, so the trick here is actually functions aren't special. Yeah, sure, they run recipes of code, but how we pass them around isn't special. JavaScript, we can pass functions to functions as variables. And we can save functions as variables. And we can save many variables that point to the same function because functions are what type of data? They're complex. So that means that when we map a variable to a function, what does the variable actually hold? A reference. So if we go back here, actually this add number function, this really only exists one place in memory. When we create this, there's one reference to add number. And all the other phone books use it. But it's smart enough to know which phone book actually called it with the this keyword. But that's just a reference to that function. In general, that's actually, in the way I built this here, it will create a new function every time. But still, the point is that we can make one function once and have many variables point to it and reuse it. So they're not special. And that means we can do cool stuff when we pass functions into other functions, like the map method I showed you yesterday, where it said, take all of these numbers, run them through the function I gave you, and give me the output in one line of code. Does that make sense? Do we have the visual there? Cool. And so today, we're not going to do map or filter. I could show you it again. We'll start with the most basic higher order function that's called for each. So I guess just to show you where we're building up to then, let's look at for each right now. what's going on here? When I do this, what am I actually passing in? Fuck. What's the difference between this one and this one? The second one, I'm invoking a function, but on the first one, I'm saying, hey, what's the value of console.log? It's a function. So, and because it's a function, we get the special ability to put the parentheses if we want to run the code inside of it. But when I just access console.log, I'm getting a reference to the actual code that will put it on the screen. So over here, am I invoking console.log? No, I'm telling for each, I want you to take this function and run it for each value that's in that array. And so when we run this code now, we get this down here. So we'll take a look at the docs right now, but basically what for each does is you give it a callback, which is a function, and you tell it, I want you to call this function back for every element in the array. And what it automatically does is it'll call your function with the current value, so the C, the current index, and then also a reference to the whole array, which we're never really are going to use. But that's why we see 3 things get logged out here. So instead, if I don't want all of that, I can instead define my own function here. So this is a very short function. I could do it as an arrow. Basically, it says take in one variable called name, and then run this code to the right of the arrow, which says go console log out name. So in this way, I've just defined my own function. This will evaluate to a reference that I give to for each. And the difference now when I run this is that even though for each called me with all 3 of those arguments, I only took in one, and I completely ignored the others. So in this way, I can just log out the current names and not have all of this as well. But to demo that, I could show you that we could take in, whoops. I could take in the name and index if I want to. And optionally, I could take in the whole array as well. And so now there really is no difference between these 2 lines of code. This one automatically took all of the arguments, and this one I specified which to take. So before we get to that, so a quick review, documentation. If I see capital A array and prototype up here, what does it mean? That means for each will be a function, a method that exists on all instances of arrays. So any array I make, I can call array.forEach. And so here they have the same example I just did, but without the arrow function. So here you see that they just declare a function in line. It doesn't even have a name. And this function takes in one element, and it just goes and calls console log with just that element. So this is almost exactly the same, just logs out A, B, C. So if we scroll down, because we want to learn how this actually works, we get the signature here. And this says that for each takes in a function, and in italics they're saying we're just going to call this thing the callback, just so we can talk about it. And then they're showing you that that callback function, the function you give it, can take in the current value, and then optionally, it can also take in the index and the array as a whole. So over here, we says that parameters, there's only one parameter. It takes a callback. Okay, it takes a second parameter, but don't worry about this one at all. So it takes in a callback function and says this is the function that you want us to execute on every element. And your function can take 3 arguments. It should take the current value, which is going to be those letters, A, B, and then C. Then optionally, we can also tell you the index that that element is at, and we could give you the whole array that you called for each on, which you'll never really go into use. Does that kind of make sense, at least how to read the docs there? Cool. So let's build up to that knowledge on how this works. So functions are special, but they're not actually special because we can pass them around like any other value. We just tend to think they're different than other values, but they're not. Strings, numbers, arrays, we're used to passing them into functions or returning them from functions, but functions seem like they're in a different category and they're like rooted to the line of code that they're defined, but they're not, because we have variables that refer to them and we can pass those variables around. So compared to other languages, JavaScript is special because it lets us do this with functions, which is that flexibility is really nice, that allows us to do those one-liners where we map over a bunch of numbers and then we filter them by passing functions around. Languages that don't let you pass functions around mean that you're going to have to type a lot more code generally. So the flexibility is great for stuff like this, but we saw that it also sucks if we take in an undefined value and store that in our phone book. So those are pros and cons of JavaScript. But in JavaScript, we say that functions are first-class objects, which means we can pass them around like anything else, and that's a really cool property of the language. So over here, we've seen that we can store a bunch of strings, numbers, whatever, in arrays, but we can also, okay, we're not there yet. We're just going to have this variable, string value happy. We push in that value 3 separate times. We log out the array. That makes sense, right? So we could do the same thing. Over here, basically this function declaration is the same. We made a variable called happy function. That's really what happened. And happy function is a reference to how to run this code. And now, am I invoking happy function on these lines? No, I'm just saying go to that variable. It's a reference. I don't care. Push it into the array. So if we log out the array, we're not calling those functions. This is just the visual to say, hey, the thing you logged out is a function. That looks similar to when we logged out console.log before, right? So that's what's inside this array. We just pushed in a bunch of functions. So how can we call them now? So in this case, we're not even pushing them in. We just hard code in that variable, which is a reference to happy function, right? Now we do our for loop here. And we pull out the element. Best practice always, we want to get rid of that I real quick, plug it in, get this variable called element. And in this case, we know that the only elements in the array are functions, right? Which means it's safe to say, go access that thing I just pulled out, which should be a reference, and we can invoke it. So after we invoke it, what output will we see on the screen? I'm happy 3 times because that function is in the array 3 times. We loop over. We knew they're all functions, so it was safe for us to invoke it every time. So,
Can we also use for each in this case instead of looping through?
okay, so you're saying this is our array,
Right.
and you want to call AmazingArray.forEach.
Yeah, so AmazingArray.forEach and then in parentheses.
And then you define a function that's going to take in what? We're way ahead right now, but I'll let you try it.
Well, I guess happy function.
Yeah, I mean, you could name it that. You're going to take in the current value, right?
Right.
And we know the current value will be this, and then this, and then this. So what would you want to do with the current value?
Run the current value.
Yeah, so it would look almost very similar to this, but just for the visual, and we're going to build up to this. That would look like so over here, we defined a function that takes in the current element, basically does the same thing as this. And then we know that everything in Amazing Array is a function, so we could call it. But here you have a pretty good visual of the difference between using for each and the for loop. Because most of this code isn't actually telling us what it wants to do. We have to translate, what is this for loop? What does it do? You know, it's pulling out elements and then it invokes them. But here, it's very easy for us to say for each value, invoke the value. Or it will get easy to see that. But yeah. And actually, the implementation of for each under the hood looks similar to this, but we'll get there. So we know that we can pass strings or any value into a function. Here we have a function that takes in a value and logs the type of that value. and we call it with a string, we get string. Review, right? So if functions are like any other value, then we can pass references to functions into other functions. Functions that take a function or return a function are called higher order functions. And someone keep count of how many times we're going to say the word function today, because it's a lot. So this time, we make a function or a variable called happy function, and now we give it back to that other function that's going to log out the type of whatever we gave it. So when this is our argument, what is this variable value? What is it actually? Yeah, it's going to be the same reference that happy function is. So if we log out the type of that reference, what will I see pop up? Yeah, type of function is function, thank God. Because what is the type of array? So how do we know if an array is an array? Thank you. So if we want happy function to run, we have to call it. So in this case, not too much changed here. We still have a function that takes in anything. And we're assuming that it must be a function because we're going to invoke whatever that is. So here we basically made a variable called happy function. It's a reference to how to run this code. And we give that reference to calls a function. Now calls a function takes in the reference and it assumes it's a function, so it will invoke it. And we will see what on the screen? What? What? I'm happy? Yes. So, putting together some other knowledge, what happens if I call calls a function with the number 10? Yeah, we're going to get an error, so think about it for a second. If instead I plugged in literally the number 10 here, what is the value of this variable, even though it's called another function? The value is 10. And so when we basically plug 10 in right here, can we invoke a number? No, so you get an error that it's not a function. Okay, so one extra step. Over here, what if I invoke happy function right here? I leave it where it is, but I invoke it. What actually gets passed to here? Okay, so if we invoke a function, what do we get back? What does it resolve to? Yeah, and that value came from what? So if we invoke a function, we get back the returned value, right? Does happy function return a value? So what does it actually return? Undefined. So if we invoke this thing, we get undefined. So we invoke it here. Now we got a single value. So that undefined is what gets passed into here. Now what happens? Error, yeah, undefined is not a function. So really important, again, console log does fucking nothing. It is useless. It's just for us to look at. But having console logs is not the same as returning at all. So if we don't have explicitly a return keyword, calling that function is going to give us back, not zilch, what does it actually give us back? Undefined, thank you. But those were examples to put together knowledge. The simple example, if we were correct, it will call and log out I'm happy. And the return value of this function is what? If I invoke this, no matter what I invoke it with, if it runs, the return value will be what? Okay, do we see a return keyword? Do we see a return keyword? So it returns undefined. What about this one? Undefined. No return keyword, it returns undefined. What does this function return? Not undefined. Okay, so we have a function called says hi. It takes in some value and it logs out hi with that value. Then we have another one called says bye. Does the same thing but with bye keyword. Then we have a function called calls with name. And in this case, it takes in a name and it takes in a callback. So when we see the word callback, it's generally just English to explain this is a function that we expect to get called back. It's like, I'm giving you this function and I want you to call it. And so that's why they're assuming it better be a function, because they're going to invoke it. Whatever it is, they're going to invoke it. So what is says hi over here? Yeah, it's a reference to this function we defined up here. So when we come into calls with name, what is the value of name? Sadie, and the callback is going to be what? Yeah, it's going to be this reference up here. So we're going to then go invoke that function. So if they passed in says hi, we're going to go back up here and pass in the name that they gave us. Now what happens? And what about down here? Exactly. And if I instead did Sadie, right here, what will happen? Yeah, why? What is the value of callback in that case? Yeah, it's a string. We can't invoke it. So that's really important that, again, the names of variables don't matter at all. We call this a callback to express our intent that this should be a callback to people reading our code, but that does nothing to stop them from passing in whatever they want. If it's not a function, the program will completely crash. Okay, so we have one function takes in a string and it returns string plus world. What's the return value of this function? Yeah, whatever string is going to be smashed with the string world. Yeah. Down here, we have a function called calls with hello. And this time, it does take in a callback, but we've named it func. And we know that it expects this thing to be a function because it's going to invoke it right here. So we now say, let's go to the calls with hello function, and let's pass it this. What is add world? Yeah, it's a reference to this thing. And so no matter what, whatever function we give it, it's going to call that function with the string hello. So now imagine if we passed in add world, we're basically calling add world with the string hello, and we're returning that. So add world, when we call it with hello, what does it return? Hello world. And so that comes back here. And we immediately return that as well. And that ends up out here getting saved into result. So this comes back to the call stack. I think I covered it a little bit before, right? Like the first thing we're evaluating is line 12, and we get paused on this line. We say result will be whatever the result is of calling calls with hello with this. So now we're paused here, and we kind of jump inside of here. We say, hey, we want to return to wherever we got called, just back out here, with whatever the result is of calling this thing. So this kind of gets paused too. So we're paused here, and we jump up here with the string hello. And we hit return hello world, so that gets kicked back to here, and we immediately return that back out to here into result. Can we follow that? Like two functions deep. Yeah.
So on line 9, is it returning hello as an argument?
Nope, so there's kind of like an order of operations, right? Return needs to return a single value. And it says I need to return whatever this is, all the way to the right, whatever that evaluates to. I don't know if it goes 10 pluses long. We need to get it down to a single value. It says, well, here, to evaluate this, I have to call a function with this argument. And so we still don't have a single value to return yet. It says, I don't know what this does. To figure that out, I have to go run this code up here. So down here, string will get the value hello. And when we need to operate over here, we say, again, I need to return a single value. So I can't return yet until I plug in the string hello here and then resolve this plus operator. So it takes the hello, it takes the world, it smashes them together, and basically says, okay, I got a single value. And it can return this out. And that comes back here and says, okay, the result of calling this whole thing was the string hello world. So it plugs that in right here. It says, I've got a single value, so I can return that out. And over here, it says, okay, calling this gave me the string hello world, so that's what I can put into result. And now I can continue to the next line. So that's a lot to talk about. I don't know if that makes sense. But if we can follow that slowly, that's important, because this is going to build up to recursion when we have a function that calls itself over and over again, maybe 100 levels deep, before they finally return all the way back out to whatever started it. But I'll go over the call stack again when we do that lecture. Does this one make sense? At least passing the function in is really important right now, and we'll get more used to functions that call functions and tracing how that happened. All right, so here we have a function that's called say to all. And this is going to take in apparently an array of names and something called say with name func, which we're assuming is a function because they're going to try to invoke it no matter whatever it is. Down here we make a list, we make an array of strings, and we define a really small function that takes in a name and logs out hello with the name. So you kind of see what we're building to here. We have a list of names, we have a really small function here that just takes in one name. So now, good thing we built this function, it takes in a list and it takes in a function. So when we call say to all right now, what will be the value of names? Names is what? It's a reference to this array, right? Because group is a reference, so the reference comes in here. Names is pointing to the same spot wherever this lives in the computer. And we pass in whatever say hello with name is, but we don't invoke it, right? So say hello with name is just a reference to this code, right? What's the return value of say hello with name? Undefined, because there's no return keyword. So now, say with name func is a reference to this, and names is group. So we set up our for loop, and basically we plug the index into names to get the current value. So here, to be short, they skipped the spot that I encourage you to do where you say let current value equal names bracket I. That's what this is, but we have to translate that in our head. So it takes out the current value, and it's going to pass it to the say with name func. Say with name func is what? Yeah, or it's this function that will call console.log with the name. So when I is 0, names I is what? Jane. So we pass in the string Jane. So we just solved that bit. We pass in the string Jane to say with name func. Jane comes here, we log out hello Jane. This function returns what? Undefined. So that was the only thing to do in our for loop. We hit this bottom curly brace, come back up here, we increment the index. Index is still less than the length, so we plug I in now. I is 1, which is Jill. And we give it to that say with name func. And we log out hello Jill. So this functionality that we have up here reminds you of what? That you haven't used yet, but I've spoken about it. For each, yeah, this is basically the implementation of for each. It's taking a name, that's taking a function, and for every single value in the array, we'll call that function. So JavaScript library built that for each for you already, which means to get the same exact functionality here, all we have to do is make an array of stuff and a little function that we want to take in one piece at a time. And then we could have just said group.forEach, say hello with name. And we would have had the same exact output on the screen. But we don't have to write any of this. We don't have to worry about brackets. We don't have to worry about for loops. We don't have to translate it. That's where the power comes in. Questions on this? Hello? Is this the same slide? Okay, here, it's basically the same exact thing that we just did. But what's one difference with that function? The callback that we're giving it, what changed? What? Yeah, it's by now, but how are we actually passing that function in this time? Yeah, so last slide, I guess I'll go show it in one more second. Last slide we had another function like in the middle here that was like says hi. And it was a function declaration. It said function says hi, whatever. And then down here all we said was says hi to pass it in. Well here we're doing the same exact thing because this, we're declaring a function here. Even though it's not like an actual function declaration, it will only exist on this one line. And basically after it runs this bit of code here to make the function, it passes that reference in to say to all. It has that reference to the anonymous function down here, and it'll log out by to each of them. Then as soon as we're done with that line, it's completely garbage collected. That function doesn't exist anymore. So this is called an anonymous function. It allows us just to define it in the one spot where we want to use it. So that's kind of similar to when I did the thing with the arrow functions, right? Like I have no way to call that arrow function later on. It only existed for that one line on line 11. Yeah.
Syntax correct parentheses outside the
Yeah, so imagine like to declare the function, right? Function keyword, parentheses, and then code block, right? That's how we declare a function. So this second parenthesis here is to close off the one that opened up here where we're passing arguments. So first argument is the array, second argument is this function, anonymous function declaration, and then yeah, we have to close off say to all to actually invoke it. So it's a different way to look at it, but this is the same as the previous slide. I'm just going to delete this up here. Do we see the difference here? I guess it's clearer if I... So the difference here is that after line 5 runs, we can still call say hello with name because we basically gave it a name. But here, after line 8 runs, we have no way to ever use that thing again. But they do the same exact thing. So again, you do whatever's most comfortable. If it makes more sense for you to do a full declaration and call it by name, even though you're not going to use it anywhere else, then do it. It doesn't matter. But generally, eventually, you'll get to the point where you're like, okay, I'm never going to use this again. I'll just define it in line here. But there's no real big difference here. And then lastly, the other one. And this is what it looks like with an arrow function, which we see gets even shorter and eventually will be easier to read. I'll explain arrows more in depth next week. So now on this example, we kind of show where this stuff gets even more useful, how we can compose processes that can work with all sorts of different functions. And this is pretty close to how a calculator actually works. So in general, you type a number into a calculator, and then you type in a symbol, and then you type in a number. And real quickly internally, the calculator is going to say, hey, if that was a plus sign, it means that I actually want to do this with those numbers. And if it's a minus sign, I actually want to do this with those numbers. So that's the one additional step. But here, basically, we have a function that will take in a number, it'll take in a recipe for what to do with two numbers, and then it will take in another number. And all it does is it calls that operation with the two numbers. So here we can make a real small plus function that takes number 1 and 2, a real small minus function, and then basically whatever you type into the calculator, I'll map to the correct function, and then call this. And this is the only spot that any calculation actually gets done. So that's kind of high level. This is a much better example of how to be really useful in real life with this stuff, because it centralizes to one spot. All calculations we'll ever do with numbers only happen right here. And that'll make it really easy for me to send stuff back to the screen from only one spot, rather than sending plus operations somewhere completely differently than how I handle minus. But that's all abstraction. The only thing we have to understand here is that when I call it down here, what will get logged out? Yeah, and so you might know that just by being able to read this here. So let's actually step through it. I want to call console.log, but before I do that, I need to give it a single value. That single value is whatever this stuff in between the parentheses resolves to. And right now, we don't know what that is. We say we have to go call the calc function with 10, this variable plus. What is that variable? It's a reference to this function here, and the number 20. So this gets paused. and we hop inside of here. And we say, hey, we want to return whatever happens when we call this variable, which better be a function, with number 1 and number 2. And we get paused right here. And now, in my example, what is the operation func? Plus. So we actually jump up here, we plug in the 10, we plug in the 20, and this returns 30. So this whole thing, calling this expression here is 30. So we can return 30, which means the result of calling calc was 30. And now we go to console.log and log 30 on the screen. And in this one, it's readable though, 40. So do we see here that while this is kind of complex at first, this is really readable down here. We can end up doing really cool stuff with this type of style. All right, the grand finale for each. Function passed into another function is often called a callback, and some built-in JavaScript features use callbacks, like for each. So for each is an array method. We saw that on the documentation. Array.prototype.forEach means that all instances that are arrays have this method. And the only thing for each does is accept a callback and an optional this argument, but no one uses it. Anyway, for each will call the callback for every element in the array. And when it does call that callback, it will give you what? It will give the callback what arguments?
The callback functions
Elements.
Yeah, so it's going to loop over the array. It's going to grab an element. What else did I say it gives you? An index, and lastly, array, which is mostly useless because if you just called for each, you probably still have a reference to that array. So we want to log all these bridges out to uppercase, but we don't want to write any fucking for loops. So all we want to do is focus on the meat of our problem. The only thing that we need to figure out for this application is how do I make something uppercase, right? So that's the real problem that we have to solve now. We don't have to think about for loops. So we're just like, let's write one little function that can take in a string and log it out to uppercase. And that's it. We call bridges, we go to the bridges array and we say, hey, for each element inside of you, I want you to call back this log uppercase function. And we know that for each will actually give us 3 arguments, but we ignore the other 2. We don't care. String is going to be what as it pertains to the array? It's going to be what? It's going to be a current value, right? So we're basically saying, go to each bridge. For each bridge, take this and call log uppercase. And it will log out Brooklyn in all caps. Then we say, go to the next one and call log uppercase with Golden Gate. And then to the next one, London. Yeah.
How would this treat nested arrays?
Yeah, so let's pretend that this is actually, there's one more pair. Let me just put it in there. Yeah, it only goes one level deep. It says whatever the current value is, that's what I'm going to give to you. And so we take in, it's not actually a string. So actually, 2 uppercase is going to fail here. But if we just logged out the string, we would see clearly that the thing is an array. This code will actually break because the array doesn't have 2 uppercase. So just pretend that instead of calling 2 uppercase, we just logged out the current value. That's what you would see here. Because the current value of this thing is an array. For each doesn't look deeper, just says, hey, I'm giving you that thing. It was this array, take it. And then I'm giving you this string, take it. So when we log out an array in console log, it would look like that generally. So in this case, we know that for each will call back with an index as well, and we want to log out which index the bridges are at. So we just modify our little helper function. Now it takes in the current value, and it takes in the current index. And what will be the first log that pops up on the screen? And next. Yep. and London is at index 2. But the only thing that we really had to figure out to make this work is what do we want to do with each value? We want to take a value and an index and we want to log them out. So we're only concerning ourselves with what the program should do, not really how it should do it. We're not manually telling the computer, go look at this and then increment this number and now look at this one. Like that's a lot of instructions that we don't need to write. And this is why programming actually gets easier the more that you do it, even though right now it seems like, wow, this is getting harder. It will get easier once these ideas settle. And I don't write for loops, except very specific cases that this won't be enough for me. Because with for each, there's no way to stop it early. It's going to go through all of the values, right? So if I need to manually stop it, I might have to write my own for loop with a condition to stop. All right, why are functions special? Why aren't they special?
They're also variables.
Yeah, which means, yeah, that's what's useful about. We can pass them around. Not all languages let us do that, so you'd have to write a lot more for loops and a lot more functions and a lot more code. And when we pass a function into another function, it's called a, yeah, and so higher order functions are any type of function that take in a callback and use it. Or functions that return functions, which we'll look at tomorrow, Monday. And our favorite callback right now is, our favorite higher order function right now is for each. Why? Because we hate for loops. We're lazy. We don't want to type more than we have to. We don't want to open up bugs, and we want to make our code readable. Bridges for each, 2 uppercase, is a lot more readable than for let I equal 0 and then all of that. But for each is actually the dumbest higher order function there is because it really doesn't do much. So we saw examples of map and filter, and I'll go crazy with it next time we meet. But generally, there are more specialized higher order functions that allow us to do even less coding. Like in one line, we could take in an array of numbers, we can triple all of them, and then we could filter them down to whichever results are still even. In one line of code. The only thing we have to write is a function that triples a number and a function that returns whether a number is even. So we open up one more project this weekend. Honestly, Sudoku, I think, this one's more fun, but I think Sudoku is a little bit tougher of a problem and allows you to practice kind of breaking apart to smaller functions. And now that we have higher order functions, you might want to redo some of those for loops and see if there's a way that you can get all of the grids, all of the rows, all of the columns into one big array. Because there's a higher order function called every, which takes a callback. And so in this case, our current value will be a set of 9 numbers. We're building up an array where each value is a list of 9 numbers. That's either a grid or row column. Are you still with me? So we want to know whether every set of 9 is a valid set of 9. So we write one other function that takes in an array of 9 numbers and returns whether that's valid. So the main line of your Sudoku problem could be as small as return whether all sets of 9 dot every is valid. And you just have to find a way to build up the sets of 9, which we could do with other smaller functions like get column, get row, get grid, and then we could wrap those in other ways. Like we could say grid dot map and pass a function to get a column, and we can use the index, which I'll show you next week, but that one would be completely dynamic based on how big the board is. I'll show you. Anyway, romance.js, this is more of a fun one, and if we have time on Thursday, we'll have a little competition. Basically how it works is you're going to write a function that takes in any body of text, a poem, short story, song, whatever it is. And basically, it's going to randomly pick some words and decide that those words should be mapped to other words that it randomly picks. So anytime we kind of want to map something to something else, what is a good data structure we could use to represent that? An object, yeah. So we can have something where we plug in the original word and then the word we want it to become. So like the first pass, we pick some words, we pick random words, and we make that object. Then the second time we go around, if we find a word that's in our hash, we can replace it with the random word that you want to use instead. So the input is going to be a body of text, and the output is going to be a body of text of however many lines they told you, and you're just going to replace a bunch of the words inside of it. And so depending on what body of text you put in, we'll vote on most human sounding, funniest, and the most romantic. So this one's more fun. I think if you have to pick between the two, Sudoku is a harder algorithm, and this one's more practice with objects. But if you have time, do it whenever, send it to us. We'll give you feedback. Then we have some shitty examples here. We'll just do this one. So this is the body of text, hard-coded into our program, but that's okay. So you have a glance, it's a bunch of words. And when we call it down here for, I guess, we want 6 lines of 10 words per line. The output will be this. And for whatever reason, this is not finished because it's still an array of strings. So if we instead wanted this array to be one big string, and each of these separate lines, what function would we use on that array? No, join. Say, take everything in here, join them together with a new line, and it'll spit out one big string. And so I don't know what this one actually was beforehand, but we see that it probably looks ridiculous now. Cool. Any questions on high order functions? Are we scared of them? A little bit, but they start to click a little bit, the idea.
Scared of objects.
Scared of objects more, okay. Yeah. But do we get a little bit excited to see that once we get how they work for each filter map, we can move away from the really shitty for loops that suck to write? I swear, coding gets easier. But right now, if you remember the diagram I showed you, you're still in the anxiety and worry and freaking out phase, right? So that's okay. It gets better. All right, as always, hit us up if you have any questions. I don't know what just happened here. But take a 5-minute break. I'll open up workshop. I'll open this up for the weekend. Send them in when you have solutions. We'll get it to you next week, probably. We will. And yeah, have a good weekend other than that.